Today we're going to talk about using files in our computer programs. So far, the big limitation to all the programs that I've written are that you need to interact with them to provide input every time. And the results that get output are only visible on the screen, and then they go away when the program's done. When we use files, we can get input from a file, and we can save output to a file. We could both in a program, or we could do one or the other. Important thing to understand about files, you really need to visualize what's going on inside the computer. And Chapter 1 tried to explain some of that and how a computer works. Bring up a little window so I can draw some stuff for you. In the computer, any file that is saved exists on your hard drive. And I know that's a beautiful illustration of a hard drive. In order for us to work with something, in order for the computer in general to work with anything, it can't just be on the hard drive. Information that you work with, any information that a computer program works with, has to be in RAM. It has to be in memory. So what we're going to do is we are going to do something in our program to create a location in memory that is associated with location on the hard drive. You should be familiar with creating location in RAM because that's what we do when we create variables. We've been creating variables for most of the semester already. We just now need to create a special kind of variable that associates a particular file that exists on our drive with that location in RAM so that we can use it in our program. And this is how the computer works. The computer has to get things out of the hard drive to put them in memory to work with them in the PU, because the CPU is what's actually doing all the calculations and the processing and the real work inside the computer. So that's what we need to keep this in mind as we do things, and the specific implementation, how we do this, is going to be different in every computer programming language that you use, but some of the concepts are the same. So the book, again, is just talking about general concepts of what you need to think about when you're using files, and then you need to consult other documentation to figure out how it gets implemented in whichever language you are using. So the first the first language that we'll use, as usual, is Raptor. Raptor is not going to work exactly like this because it's designed for quick modeling and doing a flowchart rather than being a full-fledged programming language, but it's still useful to be able to work with files with her. So let's take a look at how we would do it. If you had no idea what to do in Raptor when it came to files, what would you do? You might not have any clue, and the book is going to help you. At this point, there's nothing over here that says anything about files. You might not know, so your options would be to search the internet or look in the input section of the learning tool or check out this. We need help working with files, so let's go to the Raptor Help and search for files. We need to know how to input from a file, and we need to know how to output to a file. This is very valuable right here. This inputting known file size, and there's also just a general section on inputting. So this is going to explain how to do that, and I'll demonstrate. All right, so here's a program that we could have written for, where we just enter two numbers and calculate the sum. Yeah, and we're going to do exactly that. We're going to read, we're going to get a text file input for this instead of doing it. I'll run. So this works, but we want to, instead of a user to have to interact with this, let's have this interact with a file. The way you do this in Raptor is with this call. You're going to make a call to redirect the input. When you redirect the input, you still use input symbols, but instead of the user have typed something in the screen, whenever the program, whenever the flowchart reaches the input symbol, it's going to look to the file. And for each input symbol, you're going to get one line from that file. Redirect input is a built-in function, so we're going to have a call to that function, but it's not going to ask to create a new tab, and we're not going to have to write in code or put any symbols in or anything. Redirect input is just something that's already known by Raptor to, instead of showing something on the screen and getting something from the user, it's going to go to a file. It's going to go to whichever file name you put here. This file could have a .txt extension, it could have a .dat extension, it doesn't matter what file extension you put here, but the important thing to remember is that whatever file name you put here, you need to have a file with exact name in the same folder as this .rap file. So if you're not sure exactly where your .rap file is, you can do as and you can see. So I'm here in my documents folder. So I'm going to bring up my documents folder here, and I'm going to create a new file here. And there's lots of ways to create a new file. Now notice I just had to put numbers there. I put numbers because I said new text file, so it automatically put a .txt extension on here. This can throw you off. If I had typed numbers.txt, it actually would have been numbers.txt.txt. You just wouldn't have seen it. There's a place in Windows XP and in Windows 7 and Windows Vista where you can show the file extensions. Right now it's automatically hiding these file extensions. So I'm not seeing any of the file extensions. So if I had typed .txt, it really would have also had another txt after it. And so if you're not sure whether you're seeing file extensions, look at your other files and see if the file extensions are being shown. See, this is a py file, but I don't see py. This doesn't have an extension, but it still says text document. This is a .txt. The other thing you could have done is I could have just started Notepad or something. I could have just typed numbers in here. Notice it automatically is going to do .txt here. Even if I type over this, it's going to add txt because of the save as type. But just be safe. And I could have done .dat, but it's a little bit trickier. It's a little bit more complicated because it's harder to open them up in files and things like that. When you have a .txt, you can just double click it and it'll open up in a Notepad. I wouldn't use a doc file because when you save something as a .doc, technically there's a bunch of other information at the top of the file. For instance, let me find a doc file here and I'll open it up in Notepad. So here's a doc file. Do edit with Notepad++. Right? Notepad++ is just going to open it to like a computer is going to see it. You can see here's data, here's the text that's in that file, but there's all this other junk up ahead of it. This is what Microsoft Word saves to save information about formatting and fonts and things like that. So there's a bunch of junk in doc files. So I would just stick to plain Notepad files. So you can save it with whatever extension you want, but just realize that Notepad is going to add the .txt automatically, and you might not see .txt when you're looking at it through Windows Explorer. All right, so now I have this numbers.txt in the same folder as this .wrap. When I get to these two input symbols, it's not going to ask me for them on the screen. It's going to go to that file. Let's see if it works. All right, I didn't get asked anything, and I see it ran again, and it said the sum of the numbers is 5. So it did happen again. All right, if we wanted to do output to a file, a similar process. We have another call, and we do direct output. If you had no idea to do this, well, it's good that you're watching this, but you could have gone help. Or you could go to the input section of learning module. There will be some occasions where you're going to want to write back to the same file you read from, but more often than that, you're going to want to save the results to a different file. This is going to prevent problems from happening here in your program. Also, Raptor is limited as to the different ways it can open files. Most computer programming languages will let you open files to append or to just write over them. Raptor just is going to completely wipe out anything. So I can give this one name I want to. I don't need to create this before the fact because Raptor is going to create it for me. It's going to save it into the folder as a .rap file. The key thing is just to put this redirect output before any of your output symbols. So if I put this down here, it's not going to do me any good because it's still going to output to the screen right here. I could put this all the way up here, 1 and 2, or I could just put it right here. Either one, doesn't really matter. So this is the result of running this program. All the master console window is telling me is that the run completed. If I go back to my documents folder, here's my results text file. Let's see. The exact same output that had been in that master console window. Instead of it going to the master console window, it went to a file. If I ran the program again, it would write what's in here. All right, so that is Raptor file input and output in a nutshell, but you're going to want to do some other things with it. One of the things you're going to want to do for a lot of the program challenges is read an indeterminate number of lines. Like if you don't know how many lines were in that file, like it wants you to count the number of numbers in one of the exercises, and it wants you to get the number of numbers and things like that. So here, it was simple. We knew we just needed to get 2 numbers. But if we didn't know how many numbers were in there, we could use a loop. And this, again, is in the help documentation. Right here. Actually here. We can do a loop. If you knew how many times you wanted to do the loop, you could do a for-type loop where you have some condition, say while number of lines read is it greater than 7 or something. If you knew the exact number of lines you had to read, you could use a loop and put that condition here. But if you don't know how many lines are in that file, you can put end of input inside the condition loop, and it's just going to keep on reading from the file. Sometimes to read into an array. For a lot of these challenges that you have to do, that's not necessary. So keep it simple. I'll do this program to use a loop. So this is a built-in thing Raptor can do, and what it's doing is just looking at the file, and as long as there's still a line of data in that file, that question is going to be answered by no, and you're going to continue the loop. So no matter how many lines were in that file, it would have looped through all of them and got it and then out it. Right, so this isn't the most useful program, I'm just demonstrating how the loop works with the end of input. You need to count the number of lines. Instead of outputting here, you would just increment count. Because this loop is going to happen for each time it goes through. You need to be sure that you have an input symbol in here, or else that line does get consumed. There's something called a read head. When this file opens, here's a representation of that file, and I had 2 in there, and I had a 4 or something. When you first open the file, there's a read head. It's here. Right? We're about to read whatever here. Every time I use the input symbol, it grabs a line and it moves the read head down here. And so if I didn't have that in symbol there, that read head would stay right here. Even though we're not doing anything with this number in a program that just counts the number of lines, we still need to have that input symbol. So read head moves and we move down. After we read the second line in this particular program, the read head moves here, and Raptor is able to identify that there's nothing here. So Raptor has that end of input be true at that point because there's nothing there. You need to make sure that text document or that document is really clean and doesn't have a book line or any unusual things in it. All right, so that's the main things you need to know in Raptor, I think. Let's talk about Python. All right, again, a simple program that we could have written weeks ago using write input from the screen. That's what this input does, gets input from the screen, stores it in a variable, adds those two variables together, and this outputs it to the screen. Okay, I wanted to, instead of getting the input from the user, from the screen, which is what input does, we want to get it from a file. If you had no idea what to do, you could try help, you could try researching online, you could check the input section of the module where you're going to find the language companion, as always. And the language companion has all sorts of information about files. You use the open function to open a file. The open function creates a file object and associates it with a file on the disk. That's this process. Open file object associates it with a file on the disk. All right, so whatever we put for file variable is this thing. It's our thing in RAM that we can use. Name of the variable reference object, name it just like any other variable. Name is a string specifying the name of the file. And Python has some different modes for reading, writing, or appending. For what we want to do now, we want to read the file. That's the first thing we want to try to do. So I'm going to do the R. That's going to be my mode. Here's an exact example. Customer file is assigned the result of the open function where we're sending customer.text as the first argument, and that's the file we want to open on the hard drive, and we're opening it up to read from it. And so in my example, this is creating a location memory called numbers file. It can be where we want, something that makes sense. That's going to be this thing. This is going to be numbers file. We're opening up the numbers text, which is the name of the file on the hard drive. We're opening up to read, so you can get information from the hard drive to RAM. We're not going to be able to go from RAM to the hard drive by opening it up with this way. Now, numbers.text, just like in Raptor, this is can be whatever file extension and whatever name you want, but if you're opening up for input, this file has to exist in the same folder as the .py file. This particular file that I'm working at is in my Python 27 folder, and you can see that up here, C Python 27 APY. I would like for you to send me these files that you're creating and working with for your programs this week too. All right, here I am in Python 27 folder off my C drive. I chose new text document from right-clicking on an open area here. I'm just going to type numbers, not .txt, because by doing new text document, it created a text document automatically with a txt extension. I could have used that same file, I could have just copied it. Now, there's something different that we didn't have to do in Raptor. In Raptor, the same input symbol was used to get input from the file or from the user. In Python, we have to do something different. This is the first example. They're talking about opening things tight, so we need to move down to opening read. Here we go. Opening a file and reading data from it. Use the readLine method. We're associating this object, this variable, with this file on the hard drive. Then when you do this name, whatever name you gave, .readLine, that's going to consume one line from that file and store it in a variable that you create called whatever you want. There's a line in the file. When we do readLine, it's moving that line, it's associating it with this object, but it's creating another variable called whatever you want, and this file, this line of text or whatever, ends up going into that variable. So in this example on the language companion, that was line 1. Line 1 is going to, when you do a read line on this object, it's going to go back to the hard drive, it's going to get a file, and it's going to read one line off of it, store it into whatever variable you want. So to convert what we have in our Python, you have to leave these on there, but shows no language companion. The numbers were 2 and 3. Sum of the numbers is 2, and then it printed 3. What's going on here? All right, here's what happened. It read those 2 numbers from my file, right? It read the 2 and the 3. Instead of adding it, it concatenated them, right? Remember the plus symbol? When the plus symbol is working with numbers, it adds them. And when the plus symbol is working with strings, it concatenates them. The numbers file is my variable. It treated Python treats a line that it reads from a file as a string. Right? It doesn't know what kind of data that is. Right? If I'd entered a string that was just a word there, it would have just concatenated them. It would have added the other. We need to tell the computer, tell Python that we're expecting to read numbers and that we wanted to actually add those numbers. The way you do that is similar to what we did with str. Remember we did str to convert numbers to strings. We need to convert strings into numbers. Reading and writing numeric data. All right, right here we need to writing numeric data. We need to do this. We need to put an int in front of our read line to convert it to an integer. Do int with an open parentheses, and then I put another close parentheses over here. Much better. It's treating them as a number now. Otherwise, it was running them in as a string. The last thing that we did in Raptor was getting an indeterminate number of lines. You're not necessarily going to know how many lines of data exist in that file, so we can use a while loop, or we can use a loop in Raptor and use that end of file as the condition. We can do something similar in Python. The documentation is the last 3 pages. It's page 14 of 18. Page 16 and 17 and 18 have some good in them. All right, this is one way to, you can use a while loop. Say, here we're reading a line, and we're saying while line is not equal to nothing, while the line is not empty, keep on getting more numbers. You can also do a for loop. You can do for variable in file object. And the way that works is the loop is going to go around, and the variable will first be the first line, and it will be the second line. And read this slowly and carefully, repeatedly. Look at the example. Here they say for line in sales file. Sales file is a variable they used when they did their open. The variable I used when I opened was numbers file. I could say for line or for number. Just this code by itself is going to associate this physical location on the hard drive with this name that I'm giving to a location in RAM, opening up that file for reading. This loop is going to go through each of the lines in that file. All right. Here's my file. It's going to go through each one of these lines, no matter how many there are. Each time it happens, instead of having this variable called line 1, I'm going to have a variable called numbers. I could have called it line, because it is going to get a line each time. In this particular program, each line is a number. I'm going to get a number, and each time the loop iterates, the line is going to go into number. So when I print number, I'll print each number in the file. So you see a print number, and it automatically put a new line character after each one. And that's not always what you want, but there's explanation in here as to how you can get that. All right, one thing we want to do is, instead of putting to this shell window, what if we want to output to another file? You don't know what to do, you check the link pin. When I date it to a file, you can either write with a W, which would erase the content that exists, or we can write in append mode, which would add to the end of the list. We'll demonstrate one. You have to put this line of code anywhere you want above where you output to the file. Now, instead of print, when print goes out to the screen, we want to do something else. Similar to how we had to do read line, we're going to do .write. Whatever we put in parentheses, it's what's going to get. I ran the program and it didn't look like anything happened. I had no user interface. I could have got input from a user and saved to a file, and then I would have seen stuff here. But in this case, I'm both getting input from a file and I'm doing my output to a file, so nothing shows up in here. The shell just comes up and it blinks. But to find out if the program ran, I need to look at the same folder where the py file is, which is C Python 7 for me, for this one. And I'm looking for a file called results.txt, which I've just gotten created. And here it is. Oh, nothing in it. Here's a big catch in Python. And the book tried to emphasize this, and it's in Language Companion. But when you do that .write, your program, here's my program. When I did that .write, I was sending what I was writing back to this object in RAM. Here, this write was associated with this output file. What is the output file? The output file is location in RAM. Yes, that location in RAM is linked to the spot on the hard drive, but the location in RAM doesn't actually, the contents of what's in RAM don't actually go back to the hard drive until you close the file. So you have to close the file, and this is all explained here. You have to close the file object.close. You should do that for getting input as well. It's a good thing to do, but you have to do it when you're doing output. It's like you only open the file one time, definitely outside of a loop. You only close the file one time. You close it when you know you're done using it. So this opened a file associated with the location RAM name that we gave it. This opened a file for writing. Now if I ran this program again, to do the same thing. As I did the W, wrote over anything that was in there. I change this to A and I run it again. It appended another 2 and a 3. That 3, it got put right after this 2 got put after the 3, because there's also something called a read head. Right? There's a read head and a write head. So the first time I ran this program, I wrote here, and the write head stopped. Wrote another line, and the write head stopped here. Actually, I did .write, right? I did .write. You can write, and you can, if you wanted to do a new line, put this \n inside quotes after whatever you write. If you put them all on the same line, you might not want that. This is going to add a new line character after this. So when I print this in the file, it's going to automatically go to the next line after each one of these. When you're doing a number, you can just a new line character in quotation marks after the number. Maybe convert the number to a string, because this is a string. So you have to have them both be strings to use the concatenation character. Number got written here, a new line went after that, and since I'm still doing append mode, it's adding on to what was there before. All right, any questions? Just go, Jason. Well, I'm going to stop the archive, but I'll stick around for a few minutes if you need anything.